I'm joined today by Sreeram Kannan, Associate Professor at the University of Washington. He's also Director of Blockchain Lab and founder of EigenLayer. So EigenLayer is one of the most talked about upcoming projects in crypto land. And it will likely enable basically the next wave of innovation. You will see why in that interview. And therefore, I welcome Sreeram and thank you for taking the time today.
Oh, thank you so much, Dominic. It's my pleasure to be here doing this podcast with you and have an opportunity to speak to the Bitcoin Suisse audience today.
Great. Let's maybe start with a brief introduction, talk a little about your background and the path towards crypto. And also, I'd be keen to know how you came up with the idea of EigenLayer.
Yeah, I'd start the story 5 years back. I was working on human genomics at the time and switched from that to start working on crypto and blockchain. And my main thesis for why I wanted to do this was that blockchains I saw to be a coordination or cooperation infrastructure, just like the internet is the information infrastructure, so or the information superhighway. And when you connect all the people through the internet, you get everybody participating in the communication, but still trust is a major bottleneck, which prevents cooperation. And blockchains are a natural evolution where if you can remove the trust bottlenecks, you can have many more people interacting more productively, forming new kinds of organizations and structures, which lets people coordinate. And I think that is a major upgrade to us as a human species, because the fundamental evolutionary advantage of humans is actually our ability to cooperate flexibly in large numbers. And I see crypto and blockchain as a major upgrade in that scenario. So when in 2018, I got into blockchains, I know I did have a background in peer-to-peer systems from long back. My PhD in 2006 to 11 was in peer-to-peer wireless systems. So I was immediately drawn to some of the core technical challenges in the blockchain space, which is how do you improve the throughput? How do you reduce the latency? How do you make these systems much more scalable? How do you make them, game theoretically more secure? All of these kinds of things. And I've been fascinated about those questions. And our initial journey was, hey, let's come up with new consensus protocols, new scalability layers, new primitives that can be then adopted by all of these different systems. And when we built the first one, it was called Prism at that time, which was a mechanism to scale proof-of-work blockchains. We went around and talked to different teams. We went and gave a talk at the Scaling Bitcoin conference, and we did not know these communities well, and I had naively assumed that if people see a good idea, they're going to immediately jump on it. But the way the governance and immutability of these systems work, it's much harder to upgrade these systems. And then we went and talked to Ethereum. Ethereum's oh, this is interesting, but maybe it takes 5 years to get to something interesting, and there is 5 ideas that we're interested in. Maybe this is one of them. So essentially, as we talked to different projects, it became clear that there are actually many good ideas out there which haven't yet made it into the kind of the most widely used crypto and projects because of a governance bottleneck. The governance bottleneck is that if there are 30 ideas for how to upgrade a blockchain, only one of them can actually then be implemented. So while a lot of the value proposition of programmable blockchains like Ethereum was essentially the ability for people to innovate at the application layer permissionlessly. If you want to build a Uniswap, if you want to build a compound Aave, any of these interesting things, you don't need to get anybody's permission. You can just come up with contracts and throw them on top of Ethereum. And you yourself don't need to be trusted. In fact, only the blockchain needs to be trusted. People just need to trust your code base, and that's good enough for many people to then start using your system. So I call this principle the separation of trust and innovation. Trust comes from the blockchain, innovation comes from the application creator. But when you go deeper through the application stack, when you go into consensus protocols, scalability, data availability, oracles, bridges, any of these other core infrastructure, they all need their own trust networks. And particularly from my own vantage point, we had these cool ideas about how to change consensus and all of these things. And we had nowhere to deploy them. And the only way to create a new consensus protocol was to start a new Solana or an Avalanche or Algorand at that time. And so we felt like, professors, and there was this pejorative term at that time called, prof coins, which is like professors starting new blockchains and new coins. And I think it was out of necessity because professors work on infrastructure, and infrastructure projects need their own trust network, and trust networks means like you have to have your own new token. So that was the system that was prevalent at that time. And we thought this was an insane barrier for many, many people. And this essentially led to what now is EigenLayer, which is how do we take existing trust networks like Ethereum and supply it to anybody who wants to build anything on top of it. So that's the idea of EigenLayer. And I can, of course, dive much deeper into it.
Okay, cool. That was already a comprehensive answer. So basically, what you're saying is that this decentralized trust layer from Ethereum that was basically previously exclusively available to dApps, right? In a permissionless fashion. Now with this restaking primitive and enabled by EigenLayer, it now opens up to all sorts of middleware, right? Maybe you can you already mentioned some, maybe you can give us a tour through all of these possible services that might soon plug into EigenLayer's set of smart contracts in order to source this security. And also just to get our followers on board, like what problems do we actually solve by doing that?
Yes. So what I'm going to do is I'll just start about like how EigenLayer, what is the goal of EigenLayer, how EigenLayer accomplishes it, and then what you can build with it. So first I'll start with what is the goal of EigenLayer. I think I briefly alluded to it, which is that, we want to expand the scope of permissionless innovation. Where can you innovate permissionlessly without actually taking anybody's permission? And one way to think about it is, how did Ethereum enable it? Ethereum enabled it by creating what I call a marketplace of decentralized trust. All of us talk about it in the crypto economy. One of the core components of the crypto economy is block space, right? What is block space? Block space, the ability to say that, in Ethereum, there is a certain notion of what is a block. And, or many, many blockchains, there's a notion of what is a block. And in a block, you can fill it with contents. And, because there is contention and competition on people using it, there is a certain price that is formed around the block. So you can think of this as a marketplace for decentralized trust. So there is a decentralized trust network that is underlying, let's say, Ethereum. And then what is happening is there's a consensus protocol and scalability layer and all of it, and a virtual machine, all of which mediate this particular decentralized trust, which use this decentralized trust, and then emerges something called block space. And now that you have this notion of a block, any application can come and consume like a portion of this block by paying the appropriate fee for it. And the economy that is built is that you are, as an application, you're consuming trust from Ethereum and therefore paying a fee. So the economy is, a trust economy. So you're selling trust. But trust has now been refined through all these particular primitives, the consensus protocol, the virtual machine, and the block limit, and all of these things together basically specify a market for decentralized trust. You can think of this as selling a refined form of decentralized trust. Like decentralized trust is the crude oil, and then you refine it, and then you get this refined product, which is block space, which is what Ethereum sells. This is a really interesting viewpoint, because if you ask it like that, where is the marketplace for crude oil? Can I just take decentralized trust and then sell it raw? And that's what EigenLayer tries to accomplish. And I explain how we try to accomplish it. What does it mean by decentralized trust? In Ethereum, you get trust by staking. Staking is you're putting down a portion of money like your ETH, and then you're saying that I am going to produce Ethereum blocks according to this consensus protocol, this virtual machine rules, all of these things. If I deviate from it, I'm ETH, in a mechanism, in a negative incentive mechanism called slashing. And so that's the core reason why Ethereum is trusted. So now if you want to supply this trust to anybody who wants to build anything, how would you do it? So that's what EigenLayer tries to accomplish. So that's what EigenLayer wants to accomplish, is to create a marketplace for general, flexible, decentralized trust, just raw trust. So how do we do it? you can start with, if staking is the root of trust, so we have to somehow do something with staking in order to kind of then pass off this trust to other people. So we invented this word we call restaking, and you could, I think, maybe even more appropriately call it as programmable staking. And what's happening is when you stake normally in Ethereum, you are saying that I'm going to validate Ethereum blocks, otherwise I'm liable to lose my deposit. And in return for my work and operation, Ethereum protocol gives me some fees, right? So that's the economy for the stakers. Stakers putting down ETH, putting their work up in making Ethereum blocks and getting a reward. What restaking does is when you stake your ETH, if I can also say that I'm going to validate not only the Ethereum protocol, but also some other protocols built on top, then, I'm validating the Ethereum protocol and maybe this new chain and maybe this new Oracle and maybe this new, data availability and all that, like many, many things built on top. Then you can say, oh, now I'm not only making a commitment to validate the Ethereum blocks correctly, but I'm also making a commitment to validate all of these other systems correctly. So EigenLayer is a set of Ethereum smart contracts that let you express this preference. The preference is I'm not only validating Ethereum blocks, I'm also validating all these other systems correctly. And so that's the core idea of EigenLayer. We call this restaking because you're staking in Ethereum and using the same stake to make these additional commitments. And how you do it is there are two different paths for how to do it. One we call liquid restaking, which is actually very easy to understand. You go and stake in a liquid staking protocol. In a liquid staking protocol, you stake and there is a redemption token called stake DETH token in Lido or RETH token in Rocket Pool. There are different liquid staking protocols. You get a liquid staking token. You take the token and deposit it into EigenLayer contracts and then say, oh, I'm validating for these like 10 other systems or 5 other systems or whatever you want to opt into. And you as a staker would opt into systems so that you're actually earning enough fees for the work that you're putting into. If a system offers less fee than the work you're putting into, you're not going to opt into it. So that's the basic economics of the free market of EigenLayer. So you have, when you restake into EigenLayer you can take any of the liquid staking tokens and then deposit it into the EigenLayer contract and then specify what you're validating for. So that's a basic, simple primitive. But if you expand beyond that, we also allow what we call native restaking. What is native restaking? You stake in Ethereum. You don't want to go through some other third-party liquid staking protocol. You don't trust them or you don't like them or you just want to do it yourself. You want to want your friend to do it, whatever it is. So what you do is you take your stake, when you deposit it into the Ethereum contracts, you set a withdrawal credential. And the withdrawal says who is allowed to withdraw it. Instead of, normally you would say, I'm allowed to withdraw it. Instead, what you say is the EigenLayer contracts are allowed to withdraw it. And in the EigenLayer contract, you say that you are allowed to withdraw it. So basically, the withdrawal goes from Ethereum to the EigenLayer contracts back to your wallet. So you're adding one step in the withdrawal process. And what it does is because you're adding this one step, now the EigenLayer contracts have a potential or a permission to impose penalties on you if you misbehave. If you don't misbehave, you're going to be able to withdraw all your ETH according to the rules of the contract. So that's the how. The first one was why we're doing EigenLayer. Now we talk briefly about how we're doing EigenLayer. Any questions on either of these things before I move on to what you can build with it?
Actually, I have some specific questions, yes, but maybe we come back to that later.
Okay. Sorry? That's awesome. No, that's awesome.
Okay. Yeah, because maybe you can also expand on the range of services that are possible.
Yes.
Because you mentioned a few like oracles and things like that. Because as I understood, the design space EigenLayer basically enables this. To me, it's very impressive. Because it opens up kind of a new dimension of possible tech stacks, right? As an example, I love the idea of Mantle, for example, like the roll-up. You most likely know it, but I think it's super cool that you can simply combine all the good stuff you want into one super flexible modular solution, but with the massive benefit of inheriting the security of Ethereum, right? So maybe you can elaborate a little on the range of middleware that we can now secure, and are there even more like examples where this new degree of freedom enables like new innovation, like Mantle, for example?
Yeah, absolutely. No, thank you so much for bringing up Mantle. I'll comment a little bit on it as we go on. So what is the degree of freedom for EigenLayer? What set of things can you build on EigenLayer? So I want to just start with, when would you call something a crypto solution or a blockchain solution? I think the core ingredient of being a blockchain solution is it somehow uses decentralized trust, right? Like that's, if you use decentralized trust, you're a kind of blockchain solution. If you don't use decentralized trust, you're potentially not a blockchain solution. So that's the, what I call a decision boundary. And so if decentralized trust is the core, like, ingredient into making of a blockchain solution, and EigenLayer is a marketplace for general purpose decentralized trust, you can see the kind of potential, fusion there, which is that any idea that you want to express, which requires decentralized trust in a way in which it is not available today, you can use EigenLayer. So that is the kind of basic like scope. And then I can go into like many examples. Okay, so let me start with the first one, which is kind of why I started EigenLayer in the first place, is new consensus protocols, right? Ethereum has a consensus, a particular consensus protocol which is actually very well designed, very thorough. The time of Ethereum is 12 minutes. Okay, suppose you come up with a new consensus protocol which can achieve finality in 1 second. That would be awesome. Like, there are new blockchains like, Solana and Sui and others like who are trying to optimize on some of these features. And the question is, what if I can get the massive security of Ethereum underwriting these new consensus protocols? Okay, now you can build any consensus protocol. Instead of going, hey, I need to figure out how to get new trust network, new token, and create all the hype around it. You have already a solid backing security system, which is Ethereum staking. Just get the Ethereum stakers to opt into your system and then provide validation. And now you have a super high throughput consensus protocol running on EigenLayer. So this is a very simple, clean example. So basically the scope of anything you can build with the new L1, you can build on EigenLayer. So that's the starting point. Okay, now, so what is happening right now in the blockchain space is everybody, when they're saying, I need this feature, therefore I'm building this new protocol. But there are a lot of other features in Ethereum and users and apps and everything that won't compose with this new feature. So each feature is being built in a silo, right? Our vision is that instead of each feature built in its own silo and you have to bootstrap a whole new blockchain for just one feature, would we build, we already have this Ethereum staking, and then if we build many people come and build interesting features on top of the Ethereum staking, these features can all concatenate to form really interesting, powerful services. And what kinds of features are we talking about? So if you're a rollup, for example, you write data to Ethereum because, you have to publish the data for anybody to double check your calculations and stuff. And so you normally write it on Ethereum. But if you had the Ethereum stakers participate in a data availability layer, but if this data availability layer is designed in a different way, you could have much more scalability. And so that's one of the first things we're doing. We took the Ethereum roadmap, there's something called dark sharding coming up in like a 3-year period. We already have basically built a version of dark sharding, but as an opt-in feature, so which is called EigenDA. EigenDA is Eigen Data Availability. So basically it's a layer which uses the EigenLayer's decentralized trust, which is Ethereum staking. And then we ourselves have built an example, which is a data availability service. And this can massively improve like the data bandwidth of rollups. Today, the Ethereum data bandwidth is 80 kilobytes per second. We're already operating at 10 megabytes per second in our test network on EigenDA. So that's an example of 200x scaling. But we think actually there's another 1000x scaling to be obtained in the next few years by kind of like having more people compete on these architectures. So that's our okay. So that's a data layer for rollups is an example. Now, like I think you mentioned Mantle. So Mantle has been our close design partner in using EigenDA. So Mantle is a general purpose rollup, which brings some aspects of the op stack some aspects of EigenLayer, some aspects of new decentralized sequencing, all of these tied together into a flexible modular stack. And in fact, even they're thinking of, starting with an optimistic rollup, migrating to a ZK rollup over time. So there is the design space there is, when you think about designing a rollup, what are all the other ecosystem features that you need, right? And, I talked about data availability. You can think of the other one is a decentralized sequencing. Right now, like layer tools have a single node which orders all the transactions. And it's a very contentious process. And, like you're pointing out, many people don't like it. And for good reasons, right? Like we build, the thumbs down that you gave there is actually an indication of what I just said in the beginning, which is that a solution, when it relies on decentralized trust, we call it a block. If it has any point of centralization, all our like alarms go off and we're like, hey, it's not really using decentralized trust. So now, sequencing is an example of, hey, I need to use decentralized trust. And EigenLayer, kind of, you can build a sequencing solution on EigenLayer that many rollups can say, oh, I'm not ordering my transactions. Each staker is ordering the transactions and then like giving it to the rollup. So decentralized sequencing is an example. We already have a design partner called Espresso, which is a really strong team out of, Stanford cryptography and so on. And they are basically building a super fast sequencing layer on EigenLayer. So that's an example of a service on EigenLayer. Then you come to like, what other problems do rollups have? Optimistic rollups have a 7-day withdrawal lag, right? And, we know it's needed for the full safety of the protocol. But the thing is, as soon as a rollup writes the data to Ethereum, if you have the computational power, you can verify its correctness or otherwise of that rollup. And what you can have on EigenLayer is, if enough restakers opt into a bridging service. And what would be a bridging service? A bridging service would run the rollup transactions and see what the correct state is and certify on it. Then you can move the data across rollups, data from rollup to Ethereum, all of these things at a much lower latency as soon as the EigenLayer committee puts up enough collateral behind that data, because that if that was wrong, those guys, like a lot of it is going to get slashed. And that's a superpower. So you can solve the bridging problem for rollups using EigenLayer. And we have many teams actively working on designing different bridging architectures on EigenLayer. So that's another example of what you can build on EigenLayer. Any questions, comments?
Wow. Okay, that's very impressive and kind of a lot to digest. And also, don't get me wrong, I love rollups, but yeah, as you said, it's kind of still in its, most of them are in its infancy, and they all have their training wheels on, and I feel like kind of EigenLayer could be a massive catalyst and accelerator in order to get to a satisfying state sooner rather than later. And yeah, as I understood, basically all boils down to this decentralized trust layer, right? And you mentioned it previously, talking about oil. I wrote down like that the economic security essentially now becomes a multi-purpose commodity, right? And now, to enhance our conception, maybe you could give us an idea about what is this like also non-fractionalized crypto-economic trust or crypto-economic security that basically or primarily Ethereum offers right now. And why is it so important to blockchain networks? And also maybe to add on, why is it so hard for other layer ones basically, or other smart contract platforms to build such a capital heavy trust layer?
Yes.
Because as of now, it's basically Ethereum, right? That's right. Kind of stands out.
That's right. So I think the reason is, great questions, by the way, and I love the comment about basically decentralized trust now becoming a commodity. And and you alluded to the crypto economics of this, and I think maybe we can dive a little bit into that. So when you're asking somebody to stake their like ETH or any other token for a certain long period of time, essentially what you're saying is that, hey, there is a kind of cost of money, which is that like I have this money and then like I could be doing other things. I could be putting it into a CD or like a deposit or into a treasury note or whatever other things in the world. Instead, I'm actually like holding it in like in a staked position. So what this means is, so firstly, why are we doing this? We're doing this because the economics induces trust, right? Because you know that if a service, if a dApp on Ethereum misbehaves, which means if it does things that it's not supposed to, that means like some Ethereum block producers violated some conditions, which means like they're liable to lose their ETH, which, 35 billion to 40 billion worth of ETH is staked. So that's a lot of money is going to get like slashed. This is a very, very capital intensive thing, right? And what is happening today with the layer ones is that each layer one has its own, capital asset, which is, you stake, this new L1 token, and you are basically now be a validator for this network. The fundamental economics there is if you had, if you want to build a new layer one and have like $35 billion, let's say $40 billion worth of stake in your new L1, then you need to be providing a 5% APR or something like that, 5 to 10% APR in order for that to be productive. So if you talk about like a 40 billion staking and a 5% APR, like that's a huge amount of money. That's $2 billion annually you have to pay in fees. Like who has $2 billion to pay like the stakers, right? Like that is a fundamental problem. So you have to be generating enough cash flow to actually sustain a certain amount of staking. So how is Ethereum able to sustain this large amount of staking? Because Ethereum has aggregated a lot of apps. No one app can pay $2 billion annual fees, right? But many, many apps together in a union are paying enough fees to aggregate it enough to actually create this, app fee revenue. So which creates more staking and more staking. So the Ethereum economy is that like the more the dApps that are built on top, the more secure the Ethereum staking layer becomes. The more secure the staking layer becomes, the more the dApps want to build on top. So you have this positive flywheel, which is actually, turbocharging the Ethereum landscape. And as a competing layer one, it's going to be very difficult for you to basically reproduce all of these network effects, unless, so it's going to take a lot of time to actually get the same flywheel going. But what EigenLayer does is even more turbocharges this loop. And the way it does it is saying that not only dApps are sharing security, now new layer ones or like new consensus protocols, new oracles, new data availability, new decentralized sequencer, new bridges, new MEV management, everything shares security. What that means is now all the fee rolls back to ETH, and the more ETH gets staked. Since the more ETH gets staked, the more security in a common layer. The more security in a common layer, the more services want to build on top. So it just like turbocharges. Instead of trying to create a new silo, it finds a place which is working in the crypto ecosystem, which is the Ethereum staking flywheel, which is the more staked, the more services, the more services, the more staked, and just broadens what a service is. Instead of a service is basically just a dApp, which is built as a EVM smart contract. A service is anything that requires decentralized trust. So it just completely opens up the Ethereum economy to participate in any idea that anybody can come up with. So that's the transformation of that EigenLayer does. And instead of now living in small silos, so another way of thinking about it is each of the dApp on Ethereum may by itself, let's say just for simplicity, there are 40 dApps on Ethereum, and each of them can sustain like $1 billion staking if they're living by themselves. But because they come together in a common security framework, they can sustain now $40 billion staking because there is, 40 into $1 billion staking that can be sustained. And the same effect now holds for every possible thing in the crypto landscape. Anything that requires decentralized trust can now aggregate onto a common security layer, thus turbocharging like one place where we have common security and a variety of services that are built on top of that common security, so that users or end user facing applications can now decide to use which set of services. Oh, I'm using this sequencer, this data availability, this consensus, and all of this, and then tie them together. It's kind of like in the cloud era, like AWS was the cloud, And now like there are many services on top, like, you have a SaaS service, a software as a service for like identity, like, you use Plaid or something. You have a software as a service for payments, which is Stripe. You have a DB as a service. And, you just tie all of these together and build your end user application. And that's the same thing we want to replicate in the crypto economy, which is that when you're building a user facing application, you should not have to build all the things. You should not have to build a new consensus, a new scaling, a new all of these things. Instead, you just tie all of them together in a very flexible semantics. And then now you can actually build whatever end user application that you want. So that's the worldview that we're looking forward to.
Okay. Yeah, super exciting. Especially like the mechanisms around these flywheel effects. I mean, you basically see them a lot kind of in Ethereum also with their developer base, right? I recently wrote about like, as they have the most developers, like you have the most flourishing DeFi protocols on top of it, and that attracts users again, and so forth, basically. Maybe we could quickly shift over to the topic user experience, kind of. I know it's very challenging for EigenLayer right now. I followed the testnet and now the mainnet announcement to align these different entities, which are stakers, operators, and services. And now I'd be keen to, or we are keen to know, how does it look from a user experience point of view? If I'm a staker, you already mentioned there are different methods, native, liquid. Do they also have different risk profiles? Also, if I stake natively, what is an eigenpot? Maybe you can elaborate on that. And on the operator side, I'm not fully sure if I grasp the full picture yet, because I wonder, like how does it exactly look like as an operator? Can I still validate on mainnet and on EigenLayer, or like how is it exactly looking like?
No, there's a lot of questions and some we're figuring out. But the high level is that there are three kinds of participants in our ecosystem. Stakers, people who bring their ETH, and or either the ETH could be a native staking, or it could come from liquid staking. Then we have node operators. Node operators are those who are actually validating the services for running, and like if it's a data protocol, downloading and storing the data. If it's a consensus protocol, running the node that participates in consensus, whatever the node software is, they're running it. So that's a operator. It could be that the staker is the same as the operator. So operator is just a role. If you want to be, if you want to say that, hey, I'm Dominic, I don't trust any of these operators, I just want to do it myself, you're welcome to do it. So EigenLayer does not enforce a fixed operator set. It's a flexible protocol where anybody can basically participate as their own operator. Okay, so you have the stakers, you have the operators, and then the third side is you have services, right? Like you have the oracles, bridges, chains, whatever set of things that need to be built on top. So it is a pretty complex ecosystem to kind of create. So what we're doing in our launch strategy is we are launching the protocol in phases. It's not like the whole ecosystem gets built in a day, right? So what we do is we would start with staking, like stakers can participate. Already we have a public testnet called the stage 1 testnet, which is essentially like restakers can participate. And I think you alluded to, how do I participate as a native restaker? If you're a liquid restaker, you just take your liquid token and then deposit it. You connect your wallet and deposit it. It's easy. So if you're a liquid staker, what you do is inside the EigenLayer system, you create something called an eigenpod. An eigenpod is like your own mini space inside the EigenLayer universe. So the eigenpod basically says, hey, here is a kind of subcontract on the Ethereum contract system that you control. It's very important that you control it, because what you're going to do is you are going to set, when you go to Ethereum and you want to stake natively, when you stake natively in Ethereum, you're going to say that the withdrawal address now goes to your eigenpod. So you come to the EigenLayer system, smart contract system, you create your own eigenpod, which is your own kind of mini spot in the EigenLayer universe. And then when you set your withdrawal credentials, you set it to your own eigenpod. because you control the withdrawal from the eigenpod. Now, essentially, the flow is money, goes from the Ethereum staking. When you withdraw it, it goes to your eigenpod. From your eigenpod, you'll be able to withdraw it. The only condition when you may not be able to withdraw your full money from your eigenpod is if you opted into a service on EigenLayer and that service had a particular slashing condition, which is you should not be, when you say that you're storing data, you should be storing data, or when you're validating a consensus protocol, you should not run a malicious software that signs two versions of the block or whatever, some kind of like a slashing condition. If that slashing condition is triggered, you may lose a portion of your ETH due to slashing, but otherwise you'll be able to withdraw from your eigenpod all your ETH, as well as any rewards that have accrued into your pod. So that's the eigenpod system. So eigenpod is a subset of, the EigenLayer universe that you create for yourself. And you can you go to Ethereum, and then when in your node software, you have to set your withdrawal address, you set it to your eigenpod. So you can have many, many validators set the withdrawal address to the same eigenpod. But I think that's the core idea, is that you have this concept of eigenpod on EigenLayer.
Okay, I understand. Yeah.
In terms of the differential risk profiles, there's no fundamental difference between liquid restaking and native restaking in terms of different risk profiles. They are pretty similar. It's just, you use liquid staking if you already trust a liquid staking provider. You would use native restaking if, you don't want to give a cut of your fees to the liquid staking provider, or you don't trust any of them, or you already have your own setup, whatever or you want to be a home staker on Ethereum. For any of these reasons, you want to be a native restaker. But you can be a home staker on Ethereum, and when you set your withdrawal address to the EigenLayer contracts, you can delegate your EigenLayer services to other people. So that is also possible. So EigenLayer is a very flexible system. So it doesn't say that. But also, if you want to run services yourself, you can run it yourself. So you also asked this question about node operators, whether node operators are only validating for EigenLayer, or they're also validating for Ethereum. They have to, of course, if you're an operator and you take in an LSD, right, a liquid staking token. So if you take in an LST as an operator, you only need to operate for whatever services are built on EigenLayer. Yes. But if you're also like a native staking operator, you're also providing additional services on EigenLayer, then you would, of course, validate both. You'd run basically both the ETH node on the one side and also any EigenLayer services that you have opted into. So we are building a general purpose interface for operators. Now, the problem for an operator is, there are going to be tens of services that they're validating, maybe hundreds or thousands in a 5-10 year period. And in that world, you have to now download and run these tens of services, right? And we provide an interface by which you can actually manage software upgrades and all of these things for these many services. We're working closely with Nethermind, which is a kind of cutting-edge protocol team in the Ethereum landscape, and in designing some of these interfaces.
Okay. Cool. A question that fits to that explanation, basically. You also mentioned it several times now already. Is the aspect of slashing. I wondered, how does that exactly look like in EigenLayer? And are there, could there evolve some minor or major risks if too many things are intertwined, kind of? And what I'm keen to know with the slashing aspect is basically what happens if I get slashed as an operator or as a restaker. For example, if I get slashed from the service, is the rest of is that stake still kind of validating mainnet then, or what happens? Or is it just lost in the EigenLayer smart contract set?
Yeah. Okay. So EigenLayer slashing is designed to be very, very conservative, which means slashing only occurs if there is a malicious action on the EigenLayer system. And what do I mean by malicious action? It is I opt into a service, and actually I I claim to store data, I don't store data. And when the Ethereum like smart contract asks me to produce my portion of the data, I don't produce it. Or I should never sign 2 blocks for a given like block number, but I actually go and sign it. Why? I'm trying to do an attack or something. So these are extremely like adversarial stakers, right? Like, so because just to zoom out a little bit, why do we have slashing in the first place, right? When you're trying to build a completely pseudonymous economy, which is what most of the Ethereum and like the blockchain broader crypto systems trying to do, is when you're trying to build a pseudonymous economy, you need conditions of compliance programmed in, right?
Yes.
A staker opts in and then he's trying to do an attack. Like that's not a kind of like a thing that there's no use for a service to say that they're getting trust from EigenLayer when a staker can come in like completely attack the protocol. They're not getting trust, they're actually getting antitrust. So that's a kind of thing that we are actually careful about. So what happens is EigenLayer slashing is designed to be firstly programmatic, which means it's actually programmed into the contract what the slashing condition is. When you're opting into a service, you know what the condition that you should not violate. And normally, if you just run the node software of that system, you will never violate that condition. So that's an assurance. Okay, so now you're running the system and maybe there is a bug in the Ethereum smart contracts that actually encode that logic and you do get slashed. There is an additional protection we call the slashing veto committee. The slashing veto committee is basically just judging whether the slashing contracts have a bug or not. If there is a bug and you get slashed due to a bug, they can veto out the slashing. They cannot add new slashing. They can only remove a trigger of slashing that comes from the contract. They can remove it. So we want the stakers to feel protected, but we also want services to get an assurance that the stakers are doing, the node operators and stakers are doing the right thing by actually running the correct software instead of like running malicious software that tries to attack the services. So that's the EigenLayer system. Is slashing is designed only for extreme things where you're trying to attack the protocol. It's not for things like, oh, I got lazy or I switched off the system or any of that. You don't have hard slashing for it. You'll only lose your rewards. You may get evicted from the service and lose your rewards, but you won't get slashed. Number one. Number two, as you opt into some of these services, you actually have protection not only from the services, but also from a common slashing veto committee, which initially we will appoint, and over time it will be like a market-based thing where many people can provide like this as a service. So that's the core security model of EigenLayer. Is you are actually, if you do your due diligence on the contracts, on the services, then you would not get slashed without violating the covenants. But furthermore, there's a protection from the slashing committee.
Okay, very interesting. Let's. I'd like to spend one more question on risk, because we see this like restaking. We see similar mechanisms, for example, in traditional finance, right? It's basically kind of a form of leverage. And I saw you talking or previously mentioning, it was in another podcast, I think, that there's currently no standardized theory of leverage and associated risk. Because, for example, like you said, basically, I just checked ultrasound again. Like Ethereum currently secures like 10x the amount that it actually has staked within its deposit contract. So I wonder, if we add EigenLayer to that system, how far can we push that leverage border, and where does it get like really dangerous, kind of? As there is no theory yet. Like, how do we know without blowing up everything?
It's a great question. So the question is how do we calculate leverage in a staking system by itself, and how restaking changes the landscape of leverage. So I want to kind of separate it into a staker perspective and a service perspective. Okay. So first, from the staker perspective, the leverage that you're taking on EigenLayer is very, very different from a leverage you would take on a DeFi protocol. Why is this? In EigenLayer, when you stake and you're saying that I'm validating 30 protocols or even 30,000 protocols, okay, in the craziest case, you know what you're opting into. And as long as you as a staker and a node operator are not malicious, you will not lose even 0.1 ETH. Okay. So the risk that you're taking is completely endogenous. You know what you're doing and you can control your node behavior. But imagine you go to a margin lending protocol and take a 10x leverage or a 30,000x leverage. Then what you're doing there is the price moves by 10% or 0.001%. You lose all your money. So the risk that you're taking on leverage is exogenous, right? Like you don't control the market price of ETH or whatever, like ETH to USD or anything that you're doing in the borrowing protocol, but you absolutely have 100% control over how you're validating your node for all these services. So firstly, I want to just segregate DeFi risk is not the same as EigenLayer risk. It's fundamentally a completely different object.
Okay.
So from the viewpoint of the services, there is some considerations. Okay, so what is the consideration? I think that's what the leverage calculation that you're talking about is on Ethereum, dApps together have a TVL maybe in $500 or plus billion, right? The Ethereum has maybe $30 billion staking. So that's the ratio that we're talking about, 10, 12x that. Okay, so you have like a much higher TVL than the amount that is at stake. And so that seems to be leverage and it seems to be risky. And like, so that's the thing that I was talking about in another podcast, that we don't have a standardized theory of leverage. So the core thing going on is that in these kind of systems, in a staking system, essentially every new dApp is adding to your TVL, right? Imagine somebody comes and builds a $1 trillion stable coin on Ethereum. Okay. That just adds to your leverage massively. You know, it's within the Ethereum programming model, but it still adds like leverage to your protocol, right? So the first thing to realize is that this issue of leverage is very similar between services built on EigenLayer versus services built on Ethereum itself. Like dApps built on Ethereum also add to leverage. Okay, so now that's something interesting. So now the question becomes like, why is it okay for Ethereum to be like 13x leveraged? And why is it not okay for Ethereum to be like 30x leveraged? So that's the question that we have to study carefully. And I think we have a very nuanced understanding of this. We're going to write a series of articles on it. But the starting point, which is what I want to mention here, is that the staking, Ethereum staking, is not protecting the entirety of the TVL. Ethereum staking is actually protecting the volume transacted within an attack window. So what can you do if you attack Ethereum, right? What you would do is you would basically create a block and then go and take the money out from an exchange or something, then create a competing alternative block where you send the money to like some other people. And what that does is that the alternative block, only one of these two, you're basically sending the same money across these two blocks. And if you can kind of withdraw more money than you will get slashed, then you kind of made a profit, right? And in Ethereum, the idea is that because you have $35 billion at stake, you know, and it's not possible the exchange liquidity is not deep enough for you to run away with anything of that magnitude within an attack period. Essentially, that's what protects it. So another way of thinking about it is that the value that you're actually securing by running the Ethereum protocol is not the total value locked, but only the total value in transit. Right? Because that is what actually, so that's what the theory of leverage actually tries to calculate. Not only tries to calculate, but also give an opportunity for market participants to express it sharply. So when you think about like Ethereum is not protecting the total value locked, it's not like a safe, it's not like a bank safe, but it's actually like UPS or FedEx, right? It's only securing the value in transit. Now you have a completely different set of mechanics that you need to think about. When you go to UPS, right, they'll ask you, how much do you want to insure your, package for? You say, oh, I want to insure it for $1,000. So if the package got lost in transit, you'd basically get like $1,000 back, right? And you have to pay a premium proportional to the $1,000. That's the same mechanics we think Ethereum should be building, and is built into EigenLayer, is the idea that when you get slashed, not all the slashed money is burnt. That's the Ethereum mechanics today. But you can actually take insurance bonds against the slashed money, and you can use it to do like a lot of interesting things. So, but that's a whole deep technical rabbit hole. But they're looking forward to actually like engaging with people once we write these articles on understanding leverage in Ethereum, understanding leverage in EigenLayer, and making sure that we build very secure systems that'll actually stand the test of time. We're talking about systems that want to last for hundreds of years. We're not here to like do some, short-term game.
Yeah, of course, fully agree. Yeah, and it definitely is an area that deserves more research. I'm very excited to see the upcoming papers. But basically, what you're saying is like there's like more overhead, and we have room left. I personally love the analogy with UPS. It's very digestible. Yeah. Okay. So we have one more question. And basically, I'd like to know from you how you envision the crypto landscape to develop in the upcoming years, especially because currently, like, I know we are still in kind of a bear market, or we're in the spring kind of, and a lot of people are still building. You see that so many CK EVMs are coming up. The modular narrative is getting stronger. EigenLayer is, in my opinion, a huge project to monitor and that might have a huge impact basically on the whole industry. And I wonder, like, how do you envision basically the landscape in the upcoming years, and what do you think, which impact will EigenLayer have on it, and also which impact will it have on DeFi? Maybe will we see, for example, less cross-chain hacks, or does it have an impact on that as well?
Yeah, I think, our hope is to expand the surface of permissionless innovation. So that is our like North Star that we operate by at EigenLayer. So Eigen, the name itself is Eigen in German for your own layer. So we want people to come up with new ideas. And we, initially as an academic, like my model of innovation was the lone wolf, like this great scientist like Einstein comes up with a great idea. And over time, I think I've come to a model of realization, which is actually everybody contributes very little. And it's by concatenation of these contributions that we get something huge. And that's what permissionless innovation is to me, is each person like brings their own unique ideas and improvements, but they all concatenate with each other and create this like massive ecosystem, which is much more like natural ecologies rather than like top down, like, hey, I direct a garden, as opposed to a forest that is emerging out of like this, wherever there is free energy to be eaten away, like a new organism grows there and tries to eat it away. And that's the same like vision we have, and which already like Ethereum lives by, but we just turbocharging this core mechanics, which is that maximize the scope of permissionless innovation. Any free energy available, there should be a space for somebody to come in and eat it away profitably, so that they have an incentive in actually creating it, as well as they get a fat share of what is going on. Okay, so that's our vision. And now, like, your question is, how does it impact the crypto economy? I think it is going to take some time before it starts impacting the crypto economy, because our immediate consumers are infrastructure builders. So it's a very unique place we are in, which is that usually when you're building a layer 1 or a layer 2, your consumers are basically like dApp builders, right? That's the developers that you want to onboard onto your system. Where we are with EigenLayer is we want to onboard infrastructure builders, which is Oracle builders, bridge builders, which is a completely like different category, and which which hasn't had a place to congregate yet on a given like ecosystem and then start building. So we're in a unique place, which is both the positive and a negative. Positive because, we're not competing with all these layer ones and layer twos, but, it's new. So we have to figure out how to kind of create the semantics and stuff for these different people to build on top. But our vision is, as you have richer services building on top of EigenLayer, when you're building an end user application, whether it's financial or social or like identity or any of these important stacks that we need for the blockchain crypto economy to flourish, they have a rich source of like features that they can concatenate to build these systems. And particularly since you brought up DeFi, which may be of interest to your audience as well, like there are many fundamental issues blocking like the DeFi landscape. Yes. And for example, one issue that I think about a lot is like, for example, if you're building a stable coin or if you're building margin lending protocol or any of these things, how you set the over collateralization ratio is dependent on the time to liquidation. And the time, because, you want to make sure that within the liquidation period, the price doesn't go down too much, right? So that's how you set the over collateralization ratio. And if you can build better systems, you can reduce the time to liquidation massively. For example, on Ethereum, imagine on EigenLayer, you can build these kinds of things. You can build event-driven actions. Right now, there's no event-driven actions. There's only like user-driven actions. Like users have to trigger liquidations, or users have to trigger, oh, my collateral is down, I'm going to refill my collateral. Whatever set of things that users are doing, they have to do it by themselves. Instead, if you had like Ethereum stakers opt in and say that whenever, this event happens, then I'll throw this transaction into the blockchain. That's a very interesting kind of a system where you have much better temporal guarantees. You can say that in every 5 blocks, these events will happen. So now you don't need to set your like over collateralization ratio to depend on like, you can liquidate in 100 blocks or 500 blocks. You can liquidate in like 5 blocks. So, there are fundamental changes to the DeFi landscape that like new features and sharp actions can bring to the DeFi economy, which I'm pretty excited about.
Yeah, that's massive. If I understood that correctly, it basically solves what oracles currently can't, right? Because they can't really interact with smart contracts, kind of.
That's right. So right now, I think you see like a small portion that some of the oracles do is they have these things called keepers, where you can ask them to trigger transactions on your behalf. But keepers are third party. They don't have any protocol role. They are not block proposers. So when they don't do their job, you don't know if they didn't do the job or the block proposer didn't accept the transaction. So you can't impose like severe penalties on them. So it's a very weak system. But when block proposers are keepers, then it completely changes the economy.
Wow, yeah, that's massive. I wasn't aware of that.
Cool. It's not something we're building. We want people to build. There are actually many, many ideas down the EigenLayer rabbit hole for people to jump in and build. And so that's what we're excited about.
Awesome. Hey, that's so exciting. EigenLayer, like, it will enable a lot. Crazy. Okay, cool. Hey, with that, thank you very much for your precious time, Sreeram. It was, I think, a great interview. And obviously, we wish you and the team best of success with the ongoing testnet, the mainnet launch that is coming in Q3, I guess. And also, thank you for delivering a tagline for that article already. I wrote down EigenLayer expand the surface of permissionless innovation.
Oh, that's
I like
awesome.
that a lot.
I love it. I love it. Dominic, it was a real pleasure having the opportunity to chat with you and having the opportunity to interact with your audience today, and look forward to other occasions to do so.